those items So these questions are some of my favorite questions that I like to ask you regarding parallel or quadrilaterals. All parallelograms are quadrilaterals or rectangles. So all of these right here, they all belong to the parallelogram family, and the parallelograms do belong to the quadrilateral family. So not all parallelograms are rectangles. What can you say about all rectangles? They are parallelograms. And so number 2, all parallelograms have opposite sides that are parallel or perpendicular? Parallel. And then 3, some parallelograms are trapezoids or rectangles? The rectangles. This is what a trapezoid looks like. Right? That's your trapezoid. A trapezoid only has one set of parallel lines, whereas a parallelogram has to have 2 pairs of parallel lines. So your vocabulary, seems like I missed something on there. No, it's just a really short page. Area is the number of square units needed to cover a given surface. Bless you. And that's what we're going to focus on today, is purely area of parallelograms and triangles only. This should be a complete review today, because you should have walked in here from 8th grade knowing your formula for area of a rectangle and area of a triangle. So number 4, find the area of each figure. Now you can count the squares, but which ones are hard to find the area given the counting of the squares? Yeah, these ones right here. But you could count half squares, right? But it kind of makes it a pain. But these 2 will line up to make one full square. Those line up to make one full square. And those line up to make one full square. So if you consider this square right here, that has how many squares in it? 3 by 3 is 9. And then you could consider, if you wanted to, you could consider this whole square here, because this half is the same as that half here. If you put this together along with this, wouldn't they make a full square? True or false? Yeah. So how many are in this whole square here? Because it's a 3 by 3 set. So now what's half of that? So that would have 4.5. And then this one here would also have 4.5, which makes your 9. And 9 and 9 is, so the whole thing has 18. And then what about, this one's easy. What's this one? You got 6 squares here and 3 squares there. 6 by 3 is 18 squared units. And then what about this one here? Yeah, the whole, just like we did this one right here. The whole square has 9. And so half of that would be 4.5. So we have 4.5 squared units for that one. Of course, there's an easier way, right? If you go back to this first page right here, and you look at these 2, aren't they identical areas? All somebody did was take this rectangle and push it over so that it looked like this. But it maintained the same area. And that's why their formulas are the same. If you look at the height of this one, what's the height of this parallelogram? 3. And what's the height of this rectangle? 3. So they both have the same height. What's the base of this rectangle? 6. And what's the base of this rectangle? 6. So they have identical heights and bases. This one's just been pushed over. All right, so let's look at that second page again. All right, I'm just messing with it. All right, here we go. Apparently it's moving around. Who knows? Oh, there we go. Terrific. A parallelogram are identical formulas. All that a parallelogram is a rectangle that's been pushed over. There's a person right here. that they're leaning on this, and they pushed it over. The only difference. And in fact, if you go back to the first page and look at, and let's go back to the first page. All right, so explain how finding the area of a parallelogram and finding the area of a rectangle are alike. What would you say? Based upon what we just looked at. What's exactly the same? But why? What's exactly the same about both of them? What is exactly the same about this and this? What do they have in common?
Space inside.
Not the, okay, yes, but what's the same about them?
They're both squares, rectangles.
They're both
Their bases are both the same, right? And their heights are both the same. So, a parallelogram is just a rectangle. Oops. Pushed over. So, if they have the same base and height, their areas are congruent. All right, so we're going to look at problem 1. So in problem 1, you have this parallelogram, and they gave you a base length of 12 and a height of 9, so we're going to fill that in. Here's your base length of 12, and it's meters, and your height of 9 meters. So if there is not a picture with your problems tonight, you will draw a picture and label the parts of that figure on the picture. I want every problem to have a picture if it doesn't. And then you're to find the area. So 100% of the time, I want to see you starting every problem out with that general formula. It's going to be called your blueprint. Because in some of your problems, they're going to give you the area of the figure and one of the dimensions, and you have to figure out the missing dimension. And if you don't get in the habit of starting with the blueprint, that formula, then plugging in is going to be difficult for you. So on this one, it's easy because they give you both dimensions and you're finding area. And so you've got 12, and I'll guarantee you that Common Core wants to see you put in your units of measure. 12 meters by 9 meters. That's a 9. And the reason for that is when we multiply 12 times 9, what do we get? Times tables for 12s. What's 12 times 9? 108. And then what's meters times meters? Meters squared. That's going to help you figure out your units of measure, because your units of measure are important in area, surface area, and volume. You can't forget those. So therefore, the area of the parallelogram is 108 square meters. So that one's just simple. And then look at example 2. A parallelogram has sides of 15, bless you, and 18. And so here's the side of 18. Where's the side of 15 going to go? Right, so this right here would be the other side of 15. So your 15 centimeters is going to go here. The height corresponding to a 15 centimeter base is 9 centimeters. So they're kind of making this a little bit more complicated than it needs to be. Aren't heights to things perpendicular? If your height is measured at a doctor's office, don't you stand straight and tall and perpendicular to the ground? Especially people who are short tend to really stand up straight because they want as many inches as they can. Sometimes tall people like to slouch over because they're, I don't know, embarrassed by their height. I don't know why. Proud of every inch that you own. So this height that corresponds to the 15 centimeter base, 9 centimeters, they've drawn it perpendicular to this base here. So that height right here, the 9 centimeters goes with that one. And that's a height to the 15 centimeters. And then they want to know what is the height corresponding to an 18 centimeter base. So here's your 18 centimeters. They want to know what is this height right here. So we're going to let that be our x. Oh, sorry, they want that labeled h. Well, we're going to label it x. So find the area. Okay, so we're going to find the area. Can we find the area of this particular parallelogram? Right here. What's the area formula of a parallelogram? Base times height. Isn't this the base of the parallelogram right now? And isn't this the height associated with that base? Okay, so we're going to find that. So we're going to plug and chug what we know. I know a base and I know a height. And so I'm going to put in my base of 15 centimeters and my height of 9 centimeters. And then we're going to multiply 15 times 9, which is what? 9 times 5 is 45. Carry the 4. What's 9 times 1? 9 plus the 4. 13. So it's 135. And then it's centimeters squared because you've got centimeters times centimeters. So the area of the whole parallelogram is 135 squared centimeters. So before we move to the other page, the point of this problem is that there can be two heights. Now I can't turn, well I guess technically I can. Hang on, let me turn my paper. Isn't that awesome? Wait, see? Okay, so I can turn my paper so that this height now is the same as my ground. I'm sorry, this base of the parallelogram is same as my ground. We could draw a height that's perpendicular to it. And shouldn't this base and this height be equal to what? The same area over here, the 135. So that's how we're going to figure out what this missing height is right here. Now, usually we don't figure this as being the height of our parallelogram, but it could be. The height could be inside. So that's what we're going to use. So I'm going to turn this back around. And we're going to do the work on this side. So then we'll call this step 1. And we're going to call this step 2 out here. So we're going to take our same area equals base times height. But this time we know our area from here. This area is going to go and be plugged into that area. So we have 135 centimeters squared. Gets plugged in for A equals, I know my base, I don't know my height, that's my h, which we called x. And so my base this time is different because the base has changed to the 18 centimeters. So how do we solve? What's happening to h right here? What operation? Multiplication. So how do you undo that? Division. So we're going to divide this by 18 centimeters. And we're going to divide this by 18 centimeters. So doesn't the 18 and the centimeters cancel here? And won't one of the centimeters cancel with one of those centimeters up top? And then somebody take 135 and divide it by 18 for me. Wait a minute, I have a calculator. Let's hope it goes in there evenly. I'm guessing it should be, oh it doesn't, but that's alright. I'm sure that they're going to allow you. So we get red. So we get 7.5 centimeters is equal to h. So that's what the height is going to be, 7.5. Now I don't particularly like a decimal answer. Why? It oftentimes can be inaccurate. This one's accurate because it's a terminating decimal. Alright, so let's look at page 2. So didn't we already do all of this up here? No. So we don't need to do that part. But the point is that you can have a height from either of the two bases of that parallelogram. The height's going to be different, but no matter which base times which height you multiply, you should get the same area, which we did. Then you're not going to have any problems tonight about triangles, but I'm going to go ahead and talk about them today, and then your homework tomorrow will deal with that. The area formula for a triangle, again, you should know, is 1/2 base times height. And based upon what we did on the first page when we were finding the area of that triangle, didn't we find the area of the square and cut it in half? I can take any triangle and I can turn it into a parallelogram or a rectangle. Wouldn't you agree that this half would be identical to that half, give or take? So if I found this whole parallelogram by taking base times the perpendicular height, height is always perpendicular to the base, and then took half of it, I'd have the triangle that I'm looking for. So triangles are derived from rectangles and parallelograms. And so, explain how finding the area of a triangle is different from finding the area of a rectangle. A triangle's area is half the area of a rectangle or a parallelogram. So, look at problem 3. Find the area of a triangle. Circle the formula you can use to find the area of the triangle. Which one are we going to use? That second one. But here's the problem. You've got to figure out which of these you're going to use because they've given you the 2 legs and they've given you the hypotenuse. The base and the height of the triangle 100% of the time are perpendicular to each other. So what are the 2 perpendicular sides on this triangle? The 5 and the 1 foot. This right here is extra information. We don't need it. But they're going to give that to you to confuse you. So and it doesn't matter which of these you choose to be your base and which one you choose to be your height. I'm going to choose that to be my base just because it looks like the ground and it's sitting on that. But technically these can be interchanged because, and here's the joy and the fun, couldn't I turn my paper like this so that my triangle is now sitting this way? Couldn't this now be my base and this be my height because they're still perpendicular to each other? So it doesn't matter how you turn that triangle so long as you choose those 2 perpendicular sides. Am I making you dizzy yet? All right. So the other part that you should notice about the lengths of these sides are what? They're different units of measure. We cannot find the area of anything when there's different units of measure. And you always want to change the bigger unit of measure to the smaller. In other words, we want to change the feet to inches. How many feet are there in, or how many inches are there in 1 foot? So there are 12 inches equals 1 foot. And so that's what they wanted here. And so 1 foot is going to equal 12 inches because that's a complete conversion ratio right there. And then we have we really don't care about the hypotenuse, but the hypotenuse is 1 foot 1 inch. How many inches is that? 13 total. And so we're going to find the area of a triangle. 100% of the time I want you to start off with 1/2 base times height. That's your blueprint. And then you're going to plug in what you know into that. So I know that my base is 12 inches and my height is 5 inches. And if you can divide, I mean, you can either multiply this together first and then divide by 2, or if one of these 2 are divisible by 2, you can divide one of them, but not both of them by 2. So for most of you, it'd probably be better if you multiplied these together. And so we get 1/2 times, what's 12 times 5? It is, and it's 60 inches squared. And what's half of 60? So it is 30 inches squared. So the area of our triangle is 30 inches squared. So the area of the rectangle or parallelogram that it came from would have been what? The 60. All right, last. Problem 4, you're going to have figures that we don't normally have an area for. You know, this looks like a little house. Sam, you apparently have to go immediately. Did you know? So this looks like a little house. We don't have a formula for that, but couldn't I find the area of this triangular top, find the area of this square base, and add them together? True or false? Yeah. And so that's what you're going to do. So you can create your own formula. And so for our purposes, our formula is going to be the area of the triangle. So our area is 1/2 base times, I'm going to call this height sub 1 or height sub t for the triangle, because the height of the triangle is different than the height of the square, plus the base of the square times the height of the square. So I'm going to say height sub s. And so the question says, suppose the base lengths of the square and the triangle in the figure are doubled to 12 inches, but the height of each polygon remains the same. How is the area of the figure affected? So let's find the original area and the new area. And so this is where they came up with a formula. Oh, by the way, you have to create your own blueprint. And so they plugged into here, they've done theirs backwards than what I did. So they plugged in here the base and the height of the square, and then the base and the height of the triangle. And so what's 6 times 6? So this is 36, and they haven't put in their units of measure, but it should be squared inches, and this should be squared inches. And the 24 came from the fact that 6 times 8 is 48, and half of 48 is 24. And so now it's 36 and 24. So we have 60 squared inches. So that's area sub 1 of the first figure. Then all they did was they doubled, and they're not really showing it here, but they changed this 6 inches into what? Oh, not the height, this one right here. They changed this 6 inches into what? If they doubled it, what are they doing? They're multiplying it by 2. So I just want you to understand that this 2 right here comes about from the fact that they're only multiplying the base by 2. If they were also multiplying the height by 2, they'd have to multiply by an additional 2. And then this 2 also comes about from multiplying the base of the triangle by 2, and the base of that triangle is 6. And so we get 6 times 6 is 36. 36 times 2 is what? Now look at what they did. I don't know why they would do this, but they took the 2 out of both of those and they factored out in front, didn't they? So you've got your 36 here. And then what's 6 times 8 from here? What's 6 times 8 from here? 48. And so that 48 goes here. I don't have room to put in my units of measure. And the 48 goes down there. So what's 36 plus 48? What's 6 plus 8? 14. And then 3 plus 4? 7 plus the 1. So you get 84. What's 84 times 2? 68. And isn't that inches squared? So now compare area of the original to area of the new. How is the area affected? It's not twice as big, is it? So let's take, we'll call it our image versus our pre-image. So let's go ahead and take our image, which is 168, and that's in inches squared, and divide it by 60 inches. What goes into both of those? 2, which leaves us with 30, which means another 2 could go into 60, right? Does 4 happen to go into 168? Yeah, so let's start with 4. So 4 goes into 60 15 times. 4 goes into 168 42 times. Does anything go into 42 and 15? What goes into 15? Only 3 and 5. Does 3 or 5 go into 42? Yep. Which one? 3. So 3 goes into 42 14 times, and 3 goes into 15 5 times. So that means that the area dilated, if you will. Whoops, let's spell it correctly. Dilated 14/5 times. So in other words, the new figure is 14/5 times as big as the old figure. And then the last thing I want you to do is your lesson check. Are you doing it? You're putting your head on the desk, Bailey. You're not doing it. So hopefully you looked at the question. They're essentially asking you, how do you find the area of ABC if you know the area of the parallelogram? And 23 says, since AC is a diagonal of the parallelogram, triangle ABC is congruent to triangle CDA. Is that true or false? Well, these sides are equal because it's parallelogram. Opposite sides are equal. And these sides are equal. Bless you. And then they share this side. So by what tells you the triangles are congruent? SSS. So that is true. The area of triangle ABC is greater than the area of triangle CDA. True or false? That's false because they're equal. The area of triangle ABC is half the area of the parallelogram. True or false? True. So if you know the area of the parallelogram, how do you find the area of the triangle? Take half the area of the parallelogram.